A certain animal weighs 30 grams at birth. During the first 4 weeks after the animal's birth, its weight in grams is given by the function w that satisfies this differential equation, dw over dt equals 0.01 w, where t is measured in days. What is an expression for w of t? At first, you might look at this and feel a little daunted or confused, but again, we have to recognize that this right here, this dw dt, where the rate of change is proportional to the value itself, this tells us we're looking at an exponential model. An exponential model. As a reminder, an exponential model is one where, in general, we're given dy dx is k, some constant, times our function, our original value. And so, in this case, we see instead of y, it's w, but it's pretty much the same system. We also know that when we have this, we can run a little shortcut where y equals c times e to the power of kt. That's the original function, the expression. And what does c represent? Well, c represents our initial value. And k represents the same thing as it was in the original function. I'll do that in red. Those k's, I'm going to draw a line, those are the same. And so in this question, we want to figure out, well, what's our initial value and what's our k? I look here. In the question itself, we're given k, and I'll box it. That's what's being multiplied by our w. That's 0.01, so I'm going to write that k equals 0.01. And what's our initial value? How much does our animal weigh at birth? I can see that it weighs 30 grams. I'm going to box that here, 30 grams at birth. So my c will be 30. So in the end, my function, w of t, I'll write this out in blue, w of t will equal c, which is 30, times e to the power of k, which is 0.01 t. And there is our final answer for the expression for w of t. And we can use this to solve a ton of different problems, but right now we're just being asked to find the expression.